Wind turbine blades are curved. Now, it would be easier just to make them straight, but that would not be very efficient. Because different curvatures at different points along the blade allow it to get energy out of the wind more efficiently. You see, on the outside of the blade is moving much faster than it is on the inside of the blade. To understand why the blade is curved differently at these points, we need to understand how wind affects objects. Now, wind is basically a bunch of particles, so let's look at one particle. If a particle strikes a surface, it imparts a force onto that surface perpendicular to the surface, and that's independent of the angle that the particle strikes the surface at. So if we look at a straight wind stream, if a wind blade is flat compared to the wind stream, there's not really any force coming from the wind. If it's straight up, the wind pushes it straight back, which on a windmill, that would basically just topple the windmill over and wouldn't make it turn. But if we angle the blade, it pushes it up and pushes it back. And that upward force is what drives it to turn. So, we can see that the force the wind imparts onto the blade forces it to move. But as it starts to move, the relative air velocity changes. Now in physics, if you're moving toward an object, it's equally valid to say that that object is moving toward you. So if you're the blade and you're moving up, it's equally valid to say that instead of you moving up, the air is actually moving downward. So if the air starts to move downward, at some point, you're no longer getting any power out of the wind because relative wind velocity is flat with the blade. So as you move upward faster, like on the outside of a blade, you have to become more vertical so that you can still get power out of the wind. And if we go back and look at the wind turbine, you can see that on the inside, the blade is clearly curved. And on the outside, it's almost flat, almost vertical. And that's because the relative wind velocity changes from the inside to the outside as the blade is moving. And as you can see on the top here, this cylinder is rounded off just so the air can easily pass over the blade. But, so if we look back here at these diagrams, we can see that on the inside of the blade, it's angled more into the wind, roughly at a 45-degree angle. But on the outside, it's angled more vertically so that it can still get power out of the wind. Well, I hope you learned why these blades are curved differently. And this also follows through with propellers, as propellers are basically the reverse. Instead of getting power out of the wind, they create wind with power, and that's why they're also curved differently as you go from the inside to the outside due to the relative wind velocity changes.